Hey there! In this video, we're going to just look at how to solve by completing the square. So first, let's recap what we already know how to do. So we've been working with vertex form a little bit here. So let's just rewrite each of these in vertex form. So recall, when we're doing this, the first thing I want to do is I want to subtract the 90 from both sides. That will rewrite it as y minus 90 equal to x squared minus 18x. Now you might have noticed I left a little bit of a space. I like to actually draw in a square since it's called completing the square, and to remind me that I'm going to add something onto the end of my trinomial here. But if I do it to one side, I have to also do it to the other side. So recall, we want this to be a perfect square trinomial, meaning that when it factors down, the two factors are the same. So to do so, remember we take the b term, which is negative 18 in this case. We divide it by 2 and we square it. So I'm looking at a negative 9 squared, which we know is 81. And since I add 81 to the right, I also add it to the left. The whole purpose of doing that is so I can factor that left side as x minus 9. So remember, it adds up to a negative 18 while multiplied to a positive 81. You might also notice it's the second step of that finding the square over there. But the whole point is so I can rewrite it as x minus 9 squared. And then on the left, we just combine like terms. So I'll be looking at a negative 9. And all together, only step left to getting in vertex form is to add the 9 to both sides. So y equals x subtract 9 squared plus 9. So in this case, just as a reminder, my vertex form should look in the form y equals a times x minus h squared plus k, where hk is my vertex. So I know my vertex of this particular equation would be 9, 9. So that would be my turning point. A ends up being 1, and that's totally fine. When I look at part B, though, that's when I'm going to deal with this coefficient in front, but all the same steps. I add 5 to both sides. So that way I can rewrite this as 3x squared plus 12x. Now, my issue here is that I can't really do that trick that b divided by 2 squared until I have x squared by itself. So I can't do it with a leading coefficient. So I'm going to factor out that 3. And I'd be left with 3 parentheses x squared plus 4x. And then the same way as before, I want to add some number. I just don't know what that number is. And I would still have my y plus 5 on the left. But keep in mind, while I still want to add that square, I'm going to be doing 3 times whatever that square was. Because just like if I look, the square is in the parentheses. I factored out that 3. So whatever I do to one side, I want to stay as consistent as possible by doing it to the other. So now that I have x squared, I could take that 4, divide it by 2, and square it. So I'm adding 4 to both squares here. And that's nice for us because here, after I do that, I can rewrite it so that it's 3 out front, but it's x plus 2 times x plus 2, which we know is the same as x plus 2 squared. On the left side, I saw y plus 5 plus 12. So we have y plus 17 equal to 3 times x plus 2 squared. And to get y by itself now and put this in vertex form, I keep everything the same, except I'm going to subtract 17 from both sides. So this time my vertex would be a negative 2, negative 17. That's where the turning point of my quadratic would happen. So we practiced those two things a bunch already. Now we're kind of taking that turn into solving. So in our previous lesson, we talked about solving and when we're using radicals in the equation. So in here, if I want to find the zeros in simplest radical form, remember, that means I'm setting y equal to 0. So 0 equals 2 times x minus 2 squared plus 36. So, minus 36. So in here, when I'm looking at something like that, keep in mind that zeros are basically telling me to find my solutions, my x-intercepts. I'm trying to solve for x. They're also known as the roots. They have many names, but really zeros, we're setting y equal to 0. So to start this off, I'm going to add 36 to both sides. And then we're going to divide both sides by 2. Now, in this moment, we are going to take the square root to get rid of that perfect square. It says in simplest radical form, so I can take a moment and think about radical 18. When I think about that radical 18 here, I know that I could break that down into 9 and 2. So I'd be looking at 3 radical 2. So that's what I'm going to have over here, 3 radical 2. But also don't forget what we talked about. Anytime you're taking the square root on your own, it's got to have that plus or minus in there. So we have plus or minus 3 radical 2. And it's going to be equal to x minus 2. And to finish this off, we add 2 to both sides. So my final answer should look like x equals positive 2 plus or minus 3 radical 2. Now, I could have kept it as plus or minus 3 radical 2 plus 2, but I think that gets a little bit messy. So I'm just trying to keep it all in a nice kind of uniform 2 plus or minus 3 radical 2. And then we just plug that into our calculator here. So you have to plug in the 2 separate ones, right? So x equals 2 plus 3 radical 2. So when I do that in my calculator, 2 plus 3 radical 2 is going to equal 6.2426. When I round that to the nearest tenth, that's 6.2. I do the same thing, x equals 2 minus 3 radical 2, because remember this represents 2 solutions. So 2 minus 3 radical 2, we get negative 2.2426. And x is going to equal negative 2.2. So to the nearest tenth, I have 2 solutions. So quadratics have 2 solutions. We can either write it as the simplest radical form with that plus or minus 3 radical 2, or we could actually find the nearest tenth, depending on what the problem tells us to. Now, let's tie it together and see why we even need this. So if I'm looking at the next exercise, it says solve by factoring. Okay, so anytime you see solve, we're setting 0 equal to y. I might write it as x squared minus 8x minus 20 equals y, or 0, because I'm replacing that y with a 0. So when I factor this, I'm thinking what multiplies to a negative 20, but adds up to a negative 8. So we're going to be looking at negative 10 plus 2. And remember, solving is basically taking all your factors and setting them equal to 0. So that means my first solution would be positive 10. And my second solution here would be negative 2. And we could write it just like that, or we could write it as our solution set of 10 and negative 2. So let's see the same idea, but now we're going to do it by completing the square. So same thing. I have x squared minus 8x minus 20 equal to 0. So the first step is to move that 20 over. So it's going to be a positive 20 because I add 20 to both sides. Now, I added that square to both sides because remember the whole point is to complete the square. So I'm completing the square. Remember, we fill that square by taking that middle term, b. So b divided by 2 squared. So negative 4 squared is 16. And then I'm able to factor this side to be x minus 4 squared equal to 36. We're going to take the square root of both sides. So when I take that square root of both sides, remember you're going to have x minus 4, but it's going to be equal to plus or minus 6. So you have two answers here. We add the 4 to both sides, so we get 4 plus or minus 6. So one of our solutions is x equals 4 plus 6. So x equals 10. My other one is x equals 4 minus 6. X equals negative 2. So you'll see we got the same answers by doing this as we did in part A. Now you might be asking yourself, well, Miss Fies, why are we doing that when completing the square takes way longer than it does to factor? Well, the reason is because if we look back to exercise 1, not all my solutions are going to be factorable. Not all of them are going to have nice terms. Sometimes we're going to get answers that have to stay in radical form. So let's see that in action here on this last exercise. So I want to solve by completing the square, and I'm going to rewrite my answers in simplest radical form. So if I rewrote this 1a, and I did x squared plus 4x minus 15 equal to 0, I could try to factor it, but the sad truth is that there's nothing that multiplies to a negative 15 that adds to a positive 4. So unfortunately, I can't use factoring here to help me. So I'm setting up my completing the square. I'm moving that 15 over. And we know we would fill that box here with 4 because we take that middle term, we divide it by 2 and square it. I'm going to factor my trinomial on the left here to x plus 2 squared, the whole point of completing the square, so that I'm rewriting it to have a perfect square trinomial that I can factor with, equal to 19. I take the square root of both sides, but recall, when I take the square root when I'm solving, it's going to be a plus or minus 19. And then the last step is to subtract by 2. And that's it. I can't I can't simplify radical 19 at all. There's nothing that multiplies with 19 other than 1 in itself, so I can't break that down. So that is my simplest radical form, and I leave my answer just like that. Remember that technically, I have x equals negative 2 plus radical 19, and x equals negative 2 minus radical 19. So there is technically still 2 solutions, but you can write it as plus or minus like I did before. Okay. So try doing part B. Pause the video. You'll notice B is not factorable, right? You can't multiply to a negative 4 and add up to 8. So pause the video here and try to complete the square for part B. So welcome back. You should have factored through, you realized you couldn't factor through. You should have went through with completing the square. And we ended up putting 16 in the squares. We factor that left side to x plus 4 squared. We got square root of 20, which we can break down. So in simplest radical form, remember, 4 and 5 multiply to that radical 20. So we get 2 radical 5, and x is equal to negative 4 plus or minus 2 radical 5. Now for C and D, I'm still going to rewrite this to try to get all my pieces together. So I could notice that 2x squared. Maybe I'll bring over that 4x first, but my real problem is this 2x squared, right? I haven't really wanted to do it. Even when I did vertex form, I didn't want to deal with that too. But before, because we were rewriting it, we had to factor it out, right? We factored out this 3 in this case, and we rewrote it. Now, the nice thing here is we noticed that we added that 36 to both sides, and then we just divided by 2 to both sides. When I'm looking at this, all I need to do to get x squared by itself is divide everything by 2. And now whatever I do to the first side, I do to the other. So I want to get rid of that 2 in front so that x squared is by itself. Plus 8x equal to a negative 2x plus 35. And same thing as before, I want to add that 2x over. I'm looking at x squared plus 10x plus some number equals 35 plus some number. And just like before, now we're ready to complete the square. So we added 25 to both. I'm able to factor 2x plus 5 squared equal to 60. X plus 5 equals plus or minus. Now remember, we're looking at that radical 60, thinking of anything that multiplies to 60. 4 and 15 multiply to 60, so we can get 2 radical 15. And to finish this off, we subtract the 5 from both sides. So x equals negative 5 plus or minus 2 radical 15. Okay, go ahead and pause the video and try to do the same thing with D. Keep in mind we are getting x squared by itself first. All right, welcome back. So this is our last problem for this video. So remember, our first idea was to get x squared by itself. So I'm dividing by 3. X squared minus 4x minus 3 equal to 0. Still not factorable, right? Like we can't multiply to a negative 3 and add up to a negative 4. X squared minus 4x plus some number equals positive 3 plus some number. I'm going to fill those boxes with a 4. And we'll factor this to x minus 2 squared equal to 7. And we can't do much with that radical, but we're going to take the square root of both sides. X minus 2 equals positive or negative radical 7. And we add 2 to both sides. So x equals 2 plus or minus the square root of 7. Okay, so that's all of our solving with completing the square. Hopefully this video makes sense to you, and then you're just going to practice some more of these in class. All right, thanks for watching, guys.